All right, I hope this is working well for you guys to go through the worksheet like this versus me giving you handwritten notes. I feel like it's just a little more concise. So for this third lesson in chapter 1, we're going over properties of numbers. This lesson seems a little cumbersome, seems like a lot because automatically your brain goes to, oh my gosh, I have to memorize these, and you don't. They are kind of, the more you see them, they'll get a little easier, I promise, but you do not have to memorize these right away. I'm not going to give you a test on just do you know these words or not. As long as you understand how to use them, even with this cheat sheet using it, then you're good to go. All right, so what we're going to do is we're going to simplify an expression using order of operations. And then for each step, we're going to list out why we did that step, okay? And the reason isn't like an explanation. Well, I think I did that because, no, the reason is the property, okay? So we're just going to go through it and I'll show you what I mean. First of all, we have the additive identity, the additive inverse, multiplicative identity, multiplicative property of 0, and multiplicative inverse. And sometimes people say multiplication instead of multiplicative, same thing. All right, so for an identity, whether it's additive or multiplicative, for an identity, it's whenever you do something to a number and the number doesn't change. So for additive identity, you're literally starting with a number, adding something to it, and the number doesn't change. So the only thing you can add to a number that doesn't change that number is 0. So the additive identity just says for any number, and here we'll use A, you could use X, whatever, A plus 0 equals itself. That number doesn't lose its identity, it stays A. So 10 plus 0 equals 10. Even though you added to it, it's still 10. 27 plus 0 equals 27. It keeps its identity, it doesn't change. Same thing with multiplication. What can you multiply a number by so that it doesn't change? Not 0, what? 1, yeah. So we can multiply any number by 1 and that number stays the same. So for the identity, for any number, that number times 1 equals itself. It keeps its identity, okay? The inverse, when we add inverses, the inverse of a number is its opposite, right? So when we're adding numbers, we're talking about positive and negative numbers. So like 2 plus, and the opposite of positive 2 is negative 2. 2 plus negative 2 equals 0. So that's the additive inverse. We're adding opposites, and the answer is always 0. 5 plus negative 5 equals 0. 7 plus negative 7 equals 0, right? Add opposites, you always get 0. For the multiplicative inverse, instead of changing the sign, we're flipping a number upside down. In other words, if you multiply a number by its reciprocal, and we're going to have examples of that in a minute. Here, let me flip this over. I'll do an example. If I multiplied 2/3 times 3 over 2, think about it. 2 times 3 is 6. 3 times 2 is 6. 6 over 6 is 1. Whenever you multiply a number by its inverse, by flipping it upside down, the answer is always 1. If I had negative 5/8 and I multiplied it by 8 over negative 5, literally just switch the top and the bottom number. Negative 5 times 8 is negative 40. 8 times negative 5 is negative 40. And negative 40 over negative 40 is positive 1. So anytime you multiply a fraction by its inverse, flip it upside down, multiply it by that, the answer is always 1. So the additive inverse is when you add opposites. The multiplicative inverse is when you multiply reciprocals. Flip a fraction upside down, multiply, and the answer is always 1. Okay, multiplication property of 0, we all know. Anytime you multiply a number by 0, the answer is 0. Reflexive, symmetric, transitive, and substitution. Substitution is easy, right? As long as you substitute a number in place of something that it's equal to, that's the substitution property. We use this one all the time. It's exactly what you think it is. It's just substitution. That's it. Reflexive, symmetric, and transitive are a little trickier. It's really easy to get them confused. We don't use these as much, but they are here. The cheat sheet's here. You can use it, okay? Reflexive is whenever a number equals itself. 3 equals 3. That's reflexive. 7 equals 7. Reflexive. That might sound like a silly property, but when we're using them to solve equations in steps, you will see it, okay? So when a number looks exactly like itself, that's reflexive, like your reflection in a mirror. If you're pretty in real life, you're not going to be ugly in your reflection. You're going to look exactly the same, and vice versa, right? Symmetric property is when we flip-flop both sides of the equal sign. That's it. So if 2 equals 1 plus 1, then that means 1 plus 1 equals 2. We just flip-flop the sides. That's it. If 3 times 4 equals 2 times 6, then 2 times 6 equals 3 times 4. We just flip-flop the equal sign sides. And then transitive property is where we cut out the middleman, right? So like if 4 quarters equal 100 pennies and 100 pennies equals $1, then we could just cut out the pennies and say that 4 quarters equal $1. We just cut out the middleman. If A equals B and B equals C, then just cut out B in the middle and go straight from A to C. That's it. All right, so let's do some examples. There's already one on this study guide for you. And like the other lessons, I've left the blank study guide here if you want to follow along and fill in. So what they've shown you is they started off with the problem, they solved it one step at a time, and for each step, they listed what property they were using, okay? So first, we are going to list the answer out step by step. Zoom in just a little bit. And then next to each step, when we're all done, we're gonna go back and look at the properties. All right, so here, first thing I wanna do here is what? I'm looking inside parentheses in the brackets, and then inside that, I have exponent, right? So I'm going to write 2 bracket 1/4 plus, and then 1/2 squared. 1/2 times 1/2 is 1/4. So that's my first step. Next, I'm going to add what's inside brackets here. So I'm going to get 2, and then 1/4 plus 1/4 is 2/4. Then I can simplify that to 2.5. And then 2 times 1/2 equals 1. All right, done. Okay, so from this step to this step, what did I do? I took this value right here, and I just changed the way it looked, right? I replaced 1/2 squared with 1/4. So whenever you replace something with something that it's equal to, that's just substitution. And I'm going to abbreviate. Substitution, that's it. Okay, then going from this step to this step, what did I do? I took what's inside brackets here, 1/4 plus 1/4, and I replaced it with 2/4. So again, when I take a value and I replace it with what it's equal to, that's substitution. Seems like pretty self-explanatory, right? Okay, going from here to here. Again, I took 2/4 and I simplified it to 1/2. Substitution. Now this last one's a little different. Throw you for a loop. What did I do to get from here to here? I multiplied 2, which is 2/1, by 1/2, and I got 1. So what do we notice here? I'm multiplying, so it might be one of my multiplication properties up here, and I'm multiplying a number by its reciprocal, and the answer is 1. I took 2/1, I flipped it, and I multiplied by 1/2, and my answer was 1. So out of these multiplication properties, which one says when I multiply by a reciprocal, the answer is always 1? Right here, the multiplicative inverse property. I'm just going to put and I'm done. Multiplicative inverse or multiplication inverse. That's it. 4 steps, 4 properties, done. Let's do the next one. I have 2 parentheses 3 times 5 times 1 minus 14 parentheses minus 4 times 1/4. Okay, first thing I got to do is simplify what's inside parentheses. This is going to be a lot of writing, a lot of steps. So I'm going to multiply 3 times 5. So 2, 15 times 1 minus 14 minus 4 times 1/4. Next, I'm still inside parentheses. I have to multiply. 15 times 1 is 15. So 2, 15 minus 14 minus 4 times 1/4. Then I still have parentheses. 15 minus 14 is 1. So 2 times 1 minus 4 1/4. Then I'm going to multiply 2 times 1, and I get 2 minus 4 1/4. I'm going to multiply 4 1/4, right? Multiply them. I stopped putting this little thing in here. It's supposed to be here. It's not 4 1/4. It's 4 times 1/4. Sorry, I misspoke. And 4 times 1/4 is just 1. And then last thing to do is subtract. 2 minus 1 is 1. So those are all my steps. My final answer is 1. So let's go through each step. To get from here to here, what did I do? I changed 3 times 5 to 15. So when I replace something with something it's equal to, that's substitution. Okay, then to get from here to here, what did I do? I multiplied 15 times 1, and I got 15. Well, that kind of reminds me of a property. I'm multiplying, but my number doesn't change. It keeps its identity. So if you go up to the top and look, that's the multiplicative identity, when a number stays the same. Okay, so then from here to here, what did I do? I replaced 15 minus 14 with 1. So going from here to here, that's just substitution. Excuse me. And then from here to here, again, I multiplied 2 times 1 and I got 2. So when you multiply a number times 1, and then that number just keeps its identity, that's the multiplicative identity. We multiplied, and it stayed the same. So then to get from this step to the next step, what did I do? I changed 4 times 1/4 to 1. Well, wait a minute, isn't 4 the same as 4 over 1? So I'm multiplying 4 over 1 times 1 over 4. I'm multiplying and I'm taking the reciprocal. And the answer is 1. So that's the multiplicative inverse. I'm multiplying, so I have to look up here at my multiplication properties, not the top two, one of these three. And I multiplied by a reciprocal, a fraction. Well, here I see a fraction. If I multiply by the reciprocal, if I flip it, the answer is 1. And that's exactly what I got down here, multiplicative inverse. And then lastly, to get from here to here, I just subtracted 2 minus 1 and got 1. That doesn't fit any other properties except for I'm taking a value and I'm replacing it with something that's worth the same thing, so that's substitution. Whenever any of the other properties don't work, your default is always substitution. Okay, so hopefully that helped. Let's do the back page. You're going to be using these the entire time. There's actually 2 more that we're going to add on here, the commutative and the associative properties. So as long as you use this chart to do your homework, it should be pretty self-explanatory. These are going to be used very little. These are going to be used a whole lot, okay? So we'll go over that. It's a participation grade, so just do your best. Don't stress, and I'll put up the answer key after I grade everybody's. Just make sure you're trying to complete it. All right, next page. On the back. So we still have those same properties we used. Now we also have the commutative property and the associative. Commutative, when you think about a commute, what is that talking about? How do you commute to school when you go to school, right? Normally, not during the pandemic. It's how you move somewhere, how you get there, right? Commutative is moving. Okay, so for the commutative property, all it's saying is when we're adding or multiplying, you can move numbers around. It doesn't matter what order they are in. The answer is always going to be the same. So you could say A plus B. That's going to give you the same answer as B plus A. It doesn't matter what order you add them in as long as you're adding. You can switch them around. You can move the terms around. Same with multiplying. When you're multiplying, it doesn't matter what order you do it in. The answer is always the same. That's the commutative property. You use it all the time. You just don't think of it. You don't give it a name. And then the other one is the associative property. So think about at school, who do you associate with? Right? Your group, your people, your friends, right? You associate with your group of people. Associative property is grouping. So all it's saying is if we're adding or multiplying, both of these 2 properties are just for adding and multiplying, nothing else. If we're adding, it doesn't matter what 2 numbers out of more than 2, what 2 we group together and add first, right? So if I have A, B, and C, it doesn't matter if I add A and B up first and then add C, or if I add B and C up first and then add A. Or I could even add A and C first and then add B. That doesn't matter. It doesn't matter how I group it. The answer is always going to be the same. So commutative property is moving the terms around. Associative property is grouping. So nothing changes. The order stays the same. A, B, C, A, B, C. What changes is how I group them, where I put my parentheses. I move that around. Same with multiplying. See, they're all in the same order. A, B, C, A, B, C. They don't move, but I group them differently. So associative is your group. Commutative is how you move. So commutative property moves terms, associative property groups terms. And here's an example. We have this whole big thing, 6, 2, 3, 5, 6, 3, 2, 5. They're in the same order. Okay, so it doesn't matter. We can change, oh, sorry, they're not in the same order. We moved these two. We switched them, but it doesn't matter because they're still equal. 6 times 2 is 12. 12 times 3 is 36. 36 times 5 is, what, the 150, and 630 is 180, I believe. And here, 6 times 3 is 18. 18 times 2 is 36. 36 times 5, again, is 180. Doesn't matter what order we move them in. They're still going to equal the same thing. So that's the commutative property. Second step, we've grouped them, right? We've grouped 6 times 3. We grouped 2 times 5, right? Doesn't matter what order we group it in. We're still going to get the same answer. So that's the associative property. Okay, then from here to here, I actually replace 6 times 3 with 18, and I replace 2 times 5 with 10. So that's the substitution property. They're just telling you what to do there, but this is the substitution property. And again, same thing. When I multiply 18 times 10 and I replace it with 180, that's the substitution property. They weren't listing properties there. They were telling you what to do. Okay, so let's do a few of these. Number 1. We have, what does it use? The property used in each step. Okay, 12 plus 10 plus 8 plus 5. I'm not 100% sure how it wants us to do this. Evaluate each expression using properties of numbers. Name the property used in each step. Maybe it wants us to group. Oh, I know what it wants us to do. Sorry. Okay, so mental math here. If I was going to add this, it's a lot easier to put together 12 and 8 and 10 and 5 than it is to add it straight across. So I'm going to move my numbers around. So I'm going to replace, I'm going to switch the 10 and the 8. Right? So since I moved numbers around, that's the commutative property. I didn't change the value of anything. I just moved numbers, right? And I was adding, so I could do it. That's commutative. Now I'm going to group the numbers together. So in the next thing, I'm going to group 12 plus 8, and I'm going to group 10 plus 5. So when you group numbers, that's the associative property. I'm going to skip number 4 because I need the room here to write. Okay, so then the next step would be to actually do it. So I'm going to replace 12 plus 8 with 20. Bring down my plus sign. I'm going to replace 10 plus 5 with 15. And going from this step to this step, I use substitution. And then again, 20 plus 15 is 35. Going from this step to this step, I just replaced 20 plus 15 with what it was equal to. That's substitution. Okay, let's do this guy. All right, so I've got fractions here. Same thing. When I'm adding, it's harder to add this in my head straight across. So I'm going to start off by grouping stuff. So I'm going to invert or switch these two numbers in the middle. So I'm going to have, I'm not going to do 10 here. I'm going to have 3 1/2 plus 2 1/2 plus 4 plus 3. So when I move my numbers around, it doesn't change the value of anything. So that's the commutative property. Now I'm going to group them. I'm going to group these two together and these two together. So that would be the associative property. When I group, doesn't matter how I group. That's what the associative property says. I can group it however I want. When I'm adding, it doesn't matter. So 3 1/2 plus 2 1/2 is 6. and 4 plus 3 is 7. So since I just replaced what these were equal to, that's substitution. And then again, 6 plus 7 is 13. That's substitution. I'm running out of room here because they're too close together. So for every single problem, you should have each step to solving, what you did, and then list why you did it next to it. Which property did you use, right? So when we started off with this problem, oh, I didn't mean to circle that 6, sorry. When we started off with this problem, the first thing we did was switch the 2 and the 3, right? I don't really know why they did that, but they switched it, right? So the commutative property says you can switch numbers around. Then from this step to this step, we grouped. The associative property says we can group stuff however we want, doesn't matter. From here to here, I used substitution. I replaced it while I was simplifying. Same thing here. So most of your steps for these answers is going to be commutative or associative, then the other one. You're going to pretty much use both of these, then substitution a couple times. Because after you move stuff and group it, then you're just substituting to solve. Let's do this one down here. I know these are a little confusing. It's easier to do it in class when we can do more examples. We're going to have our live Q&A later in the week, so I hope you guys attend and we can actually speak. I don't have to look at you if you don't want your camera on or whatever, but we can actually speak and you can ask me questions and I can answer them live. That'll be nice. All right, here, so I'm adding 3.5 plus 8 plus 2.5 plus 2. I'm going to group my decimals together. So first thing I'm going to do is move. Change the order, 3.5 plus 2.5 plus 8 plus 2. The commutative property says I can move stuff around and it won't change anything. Then I'm going to group them, so 3.5 plus 2.5 and 8 plus 2. Mental math, that's easier for me to add. The associative property says that I can group stuff and it doesn't change anything. 3.5 plus 2.5 is 6. 8 plus 2 is 10. Going from this step to this step, I use substitution. And I got one more. I'm just going to abbreviate. 6 plus 10 is 16. So again, replacing 6 plus 10 with something it's equal to is also substitution. Kind of see a pattern how these are working. Excuse me. So it's always easier to first solve step by step. Don't do anything in your head. If you're changing something, write it down because it is a step. And then after you're done writing out every step, you can list what property went with each step. Okay, and message me with questions. I am more than happy to help you. I know this is a little bit of a tedious, confusing lesson. Okay, thanks.